It's not the kind of relationships y'all are talking about. All right, guys, if y'all put your computers away. Relations. All right. So a lot of this you should have seen it. No, Walker.
No, it's his birthday.
Happy birthday. Now go back to your seat.
No, it's his birthday. No.
All right. Tell me. I'm going to remind you of that now.
What?
Because y'all want to be kids when it's convenient. You want to be grown when it's convenient. Okay. Tell me what this is. A graph. There are 4 quadrants. What altogether is this called? The what?
The X and Y axis.
Okay, X and Y. Which one is this? Okay.
It's definitely X.
And it's this Y. What's another name that we call it?
Can you tell us what it starts with?
C. Coordinate plane. That's exactly right.
I knew it.
See, I ain't gonna be able to write
And they're
that.
like, in the quadrants are like Roman numerals.
They are. So, what quadrant is this one? 1. Quadrant 1 is where everything is always positive.
Yep.
And then which way do they go?
To,
That's right. So this would be quadrant 2,
Quadrant 3.
quadrant 3,
And then quadrant 4 is next, obviously.
quadrant 4. All right, so we know that this is the y-axis. We call these axes here. So this is the y-axis, followed by the x-axis. X is always the horizontal axis. Y is always the vertical axis. What is this point called? The origin. That's always called the origin. And when we name points in the coordinate plane, I know it's this pen. Oh.
It's not cash money.
When we name points in the coordinate plane, hold on. Right. When we name points in the coordinate plane, how do we name them? In other words, how might I name this point in the origin? X and Y, that's exactly right. So 0, 0. Whenever I name points, the X always comes first, followed by the Y. Does that make sense to everybody?
No,
Yeah.
it's all of you.
Thank you, David. Remember, X gets bigger to the right, smaller to the left. So this would be +1, +2, +3. Whereas to the left, it would be -1, -2, -3, and so on. Okay. For Y's, up and down, okay, I would have positive going this way and negative going this way. Everybody okay on that? Let's look at some points in the coordinate plane and see if we can graph them. For some reason, this is always a struggle. I'm just going to set up a nice little coordinate plane here. As I set this up, when we put the X and the Y together as a coordinate, what's another name for that? What do we also call it? A point, a coordinate, what's another name? Ordered pair. These are all the same for naming X and Y. Let me get a volunteer. Each of you, I need 4 volunteers actually. 1, 2, 3, 4. Y'all were the first ones. All right, come on.
I volunteered to.
Ariana, plot the point. You volunteered for. You knew it was volunteered for.
I'll do it first.
You're each gonna plot one in a different coordinate, and you can use that pen. It'll still plot on there. Plot the point 1, 3.
So over one.
So tell us what you're doing. That's right. Over 1. Okay, put the point on there. Like put a point, and label it for me so we know.
What do you mean?
Here, we'll do 1 like this.
Oh, okay.
Good job. Good job. All right, hand the pen off. Plot the point. Good job. Good job. Y'all give them a point to plot. Somewhere that's on the graph.
4, 9.
Okay, on the graph. We only went up to like 5s on the graph.
-4, -2.
-4, -3. Whoa.
Wait, hold on, what was it?
-4, -3. -4. So I'm going to go. She knows how to do it.
And negative what?
3.
It's 4 negative. Right here.
Good job.
Negative.
Label it for us. -4. Good job. It's hard to write. I know. Here, I'll do it on my end. There you go. -4, -3. Perfect. All right, give them another one. -2, 2. CJ said y'all ain't got nothing on him. You just gotta go slow with it because it's running through 2 software programs whenever you write on the board. There you go. -2, 2. Good job. One more.
5, -2.
5, -2. Good job. It's kind of hard here. There you go. Just write. I'll write the coordinate. All right. Thank you. Good job, guys. Thank you for volunteering. All right. CJ, put that laptop up. All right. Is everybody okay with graphing points? Is what I'm trying to get at. Okay. The X followed by the Y. Everybody all right on that? You'll be surprised how many times students miss things because they go left instead of right or up instead of down or they get X and Y mixed up. So we need to be very, very confident in graphing points. Everybody okay? All right. Let's talk about relations then. If I have, and let's use these same points that we already used. I would, that's okay. Y'all have them written down so you can call them out to me? Give me those points we just did. 1, 3. And 5, -2. Thank you, guys. All right, so together we can put these points together and we can say that they form a relation. And so maybe we make a table. And so in my table, all the X coordinates go in one column under X. So, And then on my Y's, but you have to put the Y that corresponds to the correct X. It's got to map to the right value. Does that make sense?
Yeah.
So the 3 needs to go with the 1. The 2 needs to go with the -2. So that I could look at this and I could tell what the coordinates are. Okay, we call that mapping. So mapping
Oh, horrible mapping.
X and Y together. The points that match up together basically is, in a nutshell, an easy way to say. What is another word for the X values? Yes, good job. Who said it? Good job.
Wait.
Walker. Domain.
Oh, yeah, and the other one is.
That's exactly right. The other is range. Shh. All right, let's look at this. Here's what I want you to do. I'm going to give you a list of points. And I want you to show them, okay, let me give them to you first. Let's say 2, 5, negative 2, 3, 5, negative 2, negative 1, negative 2. I want you to show me these points as a table. A graph. And then we're going to do some mapping. This is a little bit different mapping because something has repeated, okay? And technically when you map, you kind of want to, let me go back to this one over here for a second. You really kind of want to draw an arrow that shows you which one goes. That's technically mapping, otherwise it's just a a table. But let's do all three of these and make sure we're good before we move on. And then I want you to tell me the domain and the range of our relation. So I'll give you just a second. All right. Yeah, you're really not, CJ. You're not supposed to be on your computer. All right, let's do a table first. What's another word for, well, let's just do it this way first. All right, so I got 2, 5, negative 2, 3, 5, negative 2, and negative 1, negative 2. That takes care of table. For graph, I just want to plot the points, right? Right.
Right.
Thank you. 2, and let me make this nice and neat for you. This is X, this is Y, I have 2, 3, 4, 5. So there is 2, 5. Negative 2, 1, 2, 3. Check your work, make sure you're getting them correct. 3, 4, and 5. So 5, 2. If you have, that should be 5, negative 2. If you have graph paper, that would really probably help you. 5, negative 2, and then negative 1, negative 2. So you should have 1 in each quadrant. Check and make sure that you do. Okay? Now, that takes care of the graph. Mapping. Here's where it's a little bit different, and here's why. When we're mapping, if you look, this Y value is repeated, right?
Yes, you have to write one of them.
So you only write it one time. So what we're going to do is we map. I need some place to do it. I'm going to just come over here and do it. So I've got 2, negative 2, 5, and negative 1. Let me erase part of this. Me too. It's like the blue circle of death. Of doom, I should say. All right, there we go. This is mapping. 5 and negative 1. So what I want to do is I'm not going to repeat anything on the Y side. I'm just going to write negative 2 once and come over here and say, okay, well, 2 goes with 5. Negative 2 goes with 3. 5 goes with negative 2, but also negative 1 goes with negative 2, okay? So it's basically a table. We're just not repeating any Y's. Is essentially what we're doing when we map. And domain and range, I would literally come to my table and say, okay, this is the domain, this is the range. Does that make sense to everybody?
Yes.
Does it make dollars?
Yeah.
Okay. As we talk about domain, range, X, Y, coordinates, and all this good stuff, we need to talk about one more name we have for X and Y variables.
The mean. Oh no. What? Bro.
So, 50 minutes.
All right, as we look at X values, okay, Also called, put AKA, you know what that is? Also known as. Give me another name for all the x values. Domain.
What?
Okay. Give me another name for x values.
Oh, wait, don't say that. What about, you know what?
I.
Integer.
Input.
Input. Remember you input x and it spits y back out for you. So input. And then one more you have to be familiar with, and this is the one we're going to spend a little bit of time talking about. And it also starts with IN.
Input. Intersect. Integer.
Independent.
Yes, independent.
Why? How? What? Oh.
Here is y. It's independent. It does not depend on the value of y. You're putting in whatever you want for x. It's an independent variable. That means that the y values, which are also known as the range or the exactly output, we can also call them dependent. Okay? The y value depends on what x is before it determines its value. Does that make sense to you? Let me set you up a problem, and I want you to tell me the independent variable and the dependent variable. In warm climates, the average amount of electricity used, I would say we live in a warm climate. I use a lot of electricity.
I do too.
I don't like to be hot.
Could it be?
Rises as the daily, I know y'all hate word problems, so that's why we're spending a little bit of time.
More than that, so
As the daily average temperature increases.
why are they called problems?
All right, in warm climates, the average amount of electricity used rises as the daily average temperature rises, okay? So we've got two variables here. So the first thing we need to do is identify both variables. What are the two things? Remember, variables mean they vary. They change values. What two things are changing value throughout the problem? Yeah. The electricity is one.
Oh,
The temperature is the other one, right?
okay.
Yes. The temperature is the other one. So what, David, don't pout, don't pout. So we need to determine which one is independent and which one is dependent, okay? So which one is independent? And sometimes it's easier to do the dependent first. You're absolutely right, Walker. The temperature is independent because it is all on its own, right? You don't have any say on what that temperature is going to be. It's independent. But the electricity, the amount of electricity you use, depends on what the temperature outside is. Does that make sense? So that's your dependent. All right. Let me show it to you as a graph and we're going to describe it. Pin it. Don't blurt this answer out when you got it.
Yeah.
Rain decreases, water level increases. Don't blurt it out just yet. Independent and dependent. The more it rains, the more the river rises.
Okay, I know what this one is.
She said do not let them hit us.
No, she said don't worry about the answer.
Okay, but it's still the
Oh my
same.
goodness. All right, so this one's easy to see two variables, right?
Yes.
1 and 2. Okay, David, you didn't get an answer last time. Which one is the independent variable?
That one too bad, actually.
It's on the rain.
See, this one's kind of harder than the last one.
It's not.
I'm kind of slow.
You're not slow, don't say that.
You're not.
The rain is.
They're independent. Yeah.
Independent, that is correct.
And the other one is dependent.
Think about it like this.
It depends on the rain.
That's right.
Yeah.
Think about it like this. If you flipped it around, if the water level rises, does that mean that the rain increased? Not necessarily. There are other factors that could force the river to rise, right? Maybe somebody opened the dam, right? All right. Let's look at this graphically because it's important that we are able to analyze this all different directions. By the way, our test on this will be this week.
Oh,
What?
I'm thinking Friday, Thursday or Friday.
Can it be on Thursday? It's Friday. That's like mine.
That's, all right, let's look at this.
I have a competition the next day.
yeah, so I'm going to take those temperature notes. But you stagnant.
The graph represents the temperature inside on a winter day. Describe what's happening.
And someone keeps turning and like over time, someone keeps turning the AC.
Or what happens with your thermostat? You see it in here. It shuts off, right? So as the temperature dips down to a certain amount,
It'll go back up,
it clicks the heat on,
but not too hot.
brings the temp back up, and then it cuts off. Then as the temperature goes back down, the heat will cut back on,
That way you
raises
save
the temperature back
energy.
in. That's right. Shh, shh, shh. Guys, George.
And money.
Okay. What about these endpoints here? What's happening here? What's happening
That's just showing
here?
when it
Yeah,
starts,
spike started.
and there's an arrow, so that just means it's going to keep going.
Uh-huh. So it's really cold, right? And somebody goes, oh my goodness, somebody go cut the heat on. It's cold in here. Okay, and so they cut it on and the temp rises to here.
It's too hot.
And then the heat cuts itself back, the temperature starts to decline, and the heat says, whoa, this is that temperature that you got your thermostat set on, right? That causes it to cut on and off. All right, and then it drops somebody here. Somebody must have cut the heat off. Didn't pay the bill, heat cut off. All right. Which one, by the way, in this scenario, which one is independent? Independent. Time X and independent always go hand in hand. So if you ever have it on a graph and you see, then you automatically know that independent is X. Questions, comments, or concerns? All right,